Hi everyone, this is a quick video to review quiz number 2, and this will be a good review for the midterm as well. So question 1 asks, what quadrant is the base of the prism located for 2 diopters base up and 3 diopters base out in the right eye? So remember our chart that we can easily produce because we should have memorized it by now, or you can have it handy, is we're going to have our glasses. This is saying the right eye. So this is the patient's right eye. Quadrant 1, 2, 3, and 4. And it's saying base up and out in the right eye. So up and out would put us in this quadrant, quadrant number 2. Question 2. What is the resultant prism for the following scenario? Remember, we're ignoring this part of the prescription. We're focusing on which eye and the base directions. So step 1 is Pythagorean theorem. We're going to do 5 squared plus 3 squared equals, and then take the square root of that. So if we do 5 squared, it's 25, plus 3 squared, which is 9, equals 34, and the square root of that is 583. Oops, is our answer. So that's the prism amount. Next, we need to find out the base direction. So remember our formula, V over H and then shift tangent, or inverse tangent. So we're going to do 5 divided by 3 equals, and my screen says 1.6 repeating. Then I'm going to hit shift tangent, and now it says 59.03 degrees, so 59 degrees. But this isn't the whole story. Remember, we need to apply it to our chart. In our chart, we have quadrant 1, 2, 3, and 4. Quadrant 1, we leave the angle A alone. Quadrant 2, we subtract 180 from angle A. Quadrant 3, we add 180 to angle A, and then quadrant 4, we subtract 360 from angle A. So for this question, let's identify which quadrant we're in. So it's the left eye, and it's down and in. So down and in would put us here in quadrant 3. So quadrant 3, we're going to take 180 and add it to this 59. So 180 plus 59 gives us 239, and we found our answer. Question 3, what is diplopia? We would have learned this from our terms and definitions sheet. Diplopia is a perceived double image from a single object. Question 4, calculate the resultant prism for the following scenario. So again, we focus on which eye, so we can draw the proper diagram. And we have 3.5 base up, 2.5 base in. So let's solve for our prism amount, resultant prism amount. 3.5 squared is 12.25, plus 2.5 squared is 6.25. That equals 18.5. The square root of that is 4.3. So that's our prism amount. And for our base direction, we're going to do our formula, the vertical over the horizontal. So we're going to do 3.5 divided by 2.5 equals 1.4. Then we hit shift, tangent, and now my screen says 54.46. So our angle A is 54.46. However, we need to apply it to the proper quadrant. So which quadrant are we in? On the right eye, up and in. Up and in puts us in quadrant 1. Quadrant 1, we actually leave that angle A alone. So that will be our answer. So 54.5 is the closest to that, and 4.3. So that's our answer for question 4. Question 5. What is heterotropia? So remember, tropia equals true, and phoria equals tendency. So heterotropia is a true deviation of the eye from normal alignment. If it were to ask heterophoria, we would say a tendency of the eye to deviate. Question 6. Resolve the below prism into vertical and horizontal components. So remember, our formula is going to be the sine of the angle times the prism amount. So if we do 195 sine times 8 equals, we're going to have a vertical measurement of 2. My calculator says minus 2.07, so you can ignore the minus sign and round it to 2 if you'd like, or 2.1. So that's vertical. Horizontal equals the cosine of that same angle times the same amount of prism. So we do 195 cosine times 8 equals 7.72. And let's go ahead and figure out the base direction. So we know it's a right eye at 195. So the right eye at 195, we know that this is 0 to 90, 90 to 180, 180 to 270, and then back to 360. So 195 falls right in here under quadrant 3. Quadrant 3 is down and out. So we have our base directions of base down for vertical and base out for horizontal. So basically, we just find our answers. So the vertical is 2.1 base down. See it there. And then we should have 7.7 base out right there. So that's our answer. Question 7. What is fusion? This should be pretty easy. It's perceiving two images as one. Question 8. Resolve the below prism into vertical and horizontal components. So again, we're going to do the sine of 135 times 7 for our vertical. And then our horizontal is going to be cosine of 135 times 7. And we're going to draw our diagram. It's a left eye. And 135 should place us between 90 and 180. So that's quadrant 2, which is up and in. So we can go ahead and put base up, base in, and do our calculation. So 135 sine times 7 equals 4.94. And then our horizontal is going to be 135 cosine times 7. And I'm getting the same number, 494. All right, now we just look for our answer. 4.9 base up. We have that. And then 4.9 base in. Base up, base in. So that's our answer. Question 9. A patient presents the following prescription. If we were to split the prism, what might it look like if we balanced to the thickness and weight as evenly as possible? All right, so the right and left eye are not far off. They're a quarter diopter difference. So I would just split this prism evenly, and I would do 5 and 5. Remember our rules. You have to maintain the original base direction in the original eye, and then we do a compounding base direction in the other eye. So base out and base out are compounding, and our two parts equal our whole. So our answer should be 5 base out, 5 base out, and that's the first option here. And question 10, why would a press-on prism be used? Um, Pretty straightforward. It's a temporary measure to assess if the prism is functioning properly. And I should also add it's an inexpensive temporary measure, which is a good way to trial a prism before investing a lot of money into a ground set of lenses. All right, so that concludes the review of quiz 2. Feel free to send me a message if you have any questions. Thank you.